Hi everyone, welcome to our video on finding a relative or finding the relative extrema with a rational powered function. So here we see rational powers are just fractions, so when the powers are fractions. All right, and if you're following from my previous video, this is now erased. I added this step 5 to the document, so it should already be there from even before this video for you. But I just wanted to add it, and we will still follow this process, though, when doing any of these types of problems. All right, so we will find the x values of all points where the functions defined as follows have any relative extrema, and then we'll find the values of any relative extrema. All right, so let's break down number 2 here. So step 1 is find the derivative. So g prime of x is, all right, so using the power rule, and it might help with the fractions to write, so I'm going to leave the 3 out, but then we would have 5/3 x minus 1 from the power. If you need scratch work, that's fine. 5/3, I always just think minus the denominator in the numerator and denominator like that to get 2/3. Okay, so there's the scratch work, and I'm just going to erase that because it wasn't really needed. Okay, so if you can do it by yourself, that's fine. And then we have minus 15. And then, again, the power would come to the front, so 2/3 x minus 1/3 from that would be 2/3 minus 3/3, which is negative 1/3. Okay, and then I'll erase my scratch work. And then now let's simplify. So we've got g prime of x is, well, that 3 and that 3 just cancel, so we have 5x to the 2/3. And then we have minus this 15 and that 3 would cancel, or at least reduce a little bit. So minus. So 15 divided by 3 is 5 times the 2 would be 10. And then x to the negative 1/3. Okay, and then now at this point, there's different ways you can proceed. With a negative power, though, I think it's best to now change it into a positive power. So it looks like that. Okay, so that way we can see we're dealing with fractions. So not even just fraction powers, but fractions as our terms. And then, well, what I want is a common denominator then. So to get that, I would multiply this by x to the 1/3 on both the top and bottom. So it's a little messy there, but I'm going to multiply that by x to the 1/3. And then that way we get a common denominator. So it's x to the 1/3 down below. And then up top, well, that 5 is still there. When these multiply, the x to the 2/3 times the x to the 1/3, remember, all it is adding the powers to each other. So 2/3 plus 1/3 would be 1. Okay, and again, I'm just going to do a little scratch work to the side. So this is what's happening. We're multiplying these, which means it's the same base. And then we would just add the powers, 2/3 plus 1/3. And that would give us 2/3 plus 1/3 would be 3/3, which is 1. And then we usually don't need to write the 1. Okay, so that's all. So this one, I'm just doing lots of little side scratch work that I'm erasing, especially because this one I had already filled in the blank. So if it's always fine to have scratch work going on with a whole sheet, another sheet of paper, but I can't really do that on the computer, so I'm just showing it there. Okay, anyway, so that in the highlight just became x. Okay, so that's all that, and let me go ahead and erase that. All this scratch work, I think it's distracting, so that's why I'm getting rid of it. Okay, and then minus still just 10 because I didn't do anything to that fraction. Okay, and then there it is. All right, so this, now we see we've got a fraction involved. So let me cloud this. So this is our g prime of x. And then we'll continue with the process. So step 2 is to set the derivative equal to 0. But we had a special rule for this. If it's a fraction, we want to set the numerator equal to 0. And the denominator. Okay, so the numerator is 5x minus 10, set equal to 0. We can add 10 and then divide by 5, and it would give us 2. And then the denominator set equal to 0, x to the 1/3 set equal to 0. Well, to get rid of that power, I would have to cube it. but it kind of really doesn't matter what the power is anyway. It's just going to be x equals 0. So if I need something to equal 0 and it's raised to a power, the only option is 0. So it is x equals 0 there. Which means that these are the critical numbers. So now that we have this solved, we have these are the critical numbers. So let me mark it. Critical numbers. Okay, so those are the two critical numbers. And then now continuing with our process, step 3 is to make the number line with those critical numbers marked. So we have 0 and we have 2. And then I know that these are x values, and then our function is g, so I'll label this as g prime, and then g right above. All right, and then now it's similar to all other ones where I want to plug in something in between these intervals. So now this is step 4. Step 4, I'm plugging in something bigger than 2, so I'm going to use 10. And we'll plug that in, well, it's g, almost wrote f, so we'll plug that into the derivative. So again, that's why I cloud it. So we used it immediately, but now we're using it again. So g prime of 10 gives us 50 minus 10 divided by 10 to the 1/3. 50 minus 10 is 40. 10 to the 1/3 is a weird number, but it is positive. So a positive to the 1/3 is still positive. And at this point, again, you could use a calculator to really verify, but it is positive. So then that's all we care about is the sign, positive. Okay, and then in between 0 and 2, I would do 1. So g prime of 1, I would have 5 minus 10 divided by 1 to the 1/3. Well, 5 minus 10 is negative 5. 1 to the 1/3 is actually 1. So remember, the 1/3 power is the cube root. So the cube root of 1 is still 1. So negative 5 over 1, that is negative. So we have a negative here. Okay, and let's get our last one. We have g prime anything less than 0. Well, I'm going to choose negative 1. If we choose negative 1, we have 5 times negative 1 is negative 5 minus 10 over negative 1. Now, let's write this. So I said the 1/3 root is the same thing as the cube root, or the 1/3 power is the same thing as the cube root, like that. And this becomes negative 15 over, well, the cube root of negative 1 is negative 1, because negative 1 times itself 3 times is still negative 1. Okay, so you can still check that. Negative 1 cubed is negative 1. So that's how you check your answer with these. This cubed is what should be under that. Okay, so, or again, you could just use a calculator and it would work just fine. Okay, so we have a negative over a negative, which becomes a positive. And so then we know that g increases, then it decreases, then it increases. And so then we know where our local maximum is. It's here, or relative. Relative max is here. And then we have a relative min here. So where it goes up to down, relative max, down to up, relative min. Okay, so then we've got it. All right, so we know where those occur, but our step 5 is to plug these values into our original function. So we need to evaluate g of 0. So back to the original function. Now I'm back to g right there. So g of 0 is, well, this one's easy. I don't need a calculator for it. 3 times 0 to the 5/3 minus 15 times 0 to the 2/3. 0 to the 5/3 and 0 to the 2/3 is still 0. Right, of 0 minus 0, it's all 0. Okay, so that's looking real good. So let me highlight relative max. When I plug 0 in, we got 0. And then when I want to plug in 2, g of 2 is 3 times 2 to the 5/3 minus 15 times 2 to the 2/3. Okay, and at this point, this one's looking like it needs a calculator for it. Okay, but let me get my highlighter going first. And then since I need a calculator anyway, I would probably still check it no matter what. Okay, so here's the last one. Let's plug in the new one. So 3x to the 5 not 45. 5 divided by 3, and then arrow key, minus 15x to the 2 divided by 3. So there's our function, and look at it, it looks a little weird. But notice it does follow our number line. So everything left of 0, it was increasing, and then it starts decrease until it gets to 2, and then afterwards it increases. So our arrows are correct, and then we see that we do have the maximum is correct. It was the 0 that we already calculated. And then our relative minimum, well, this already marks it. Since we needed a calculator anyway, we're going to round this to 2 decimals, negative 14.29. Okay, so that's that, negative 14.29. Okay, so there we go. So, and then just be careful, make sure you write it out correctly. So that's why I use those highlighters. So the relative max is that y coordinate of 0 at this x coordinate of 0. And then our relative minimum, so in the pink, is the negative 14.29 at this x coordinate of 2. Okay, so don't accidentally say the relative max is the relative min. Just make sure you finalize it all correctly. Okay, so that's our scenario there. So again, if you have a negative rational power eventually, like we did in the derivative, I usually recommend that you make it into a fraction. And then it usually, one of the numerator usually simplifies pretty nice. Okay, so like it did here. But then again, it's still the same old process all the way through. And as I've said before, the calculator, you might want to just use the calculator right away. You can get your answer. But make sure you still know how to do the calculus type of stuff for other scenarios. Okay, so that's it. We'll take a pause. I'm going to keep breaking these into their own separate videos. So thank you for watching, and we'll see you next time.